Our focus standard for this lesson comes from grade 7, Ratios and Proportional Relationships, Standard 2, B and C. Identify the constant of proportionality, the unit rate, in graphs and write an equation. Our topic for this lesson comes from our unit Proportional Relationships, Proportional Graphs, and Equations. Our essential question is, how can we identify the constant of proportionality from a graph and use it to write an equation? Please take a moment pausing the video if you need to copy down the topic and essential question in your header along with today's date, save your question column in your note column, and resume the video when you're ready to begin. So let's start with a few reminders about proportional relationships. First of all, if we're writing an equation for a proportional relationship, we learned in the last lesson that we use the form y equals kx, and k, that variable, is representing the constant of proportionality, which is our unit rate. So, with that, let's go ahead and take a look at our first graph. So here's our graph. Our x-axis is down here, always the horizontal one. And here's our y-axis. On both of them, we're going by a scale of 1. And this graph is showing us a recipe of making juice from concentrate. So x represents the cups of concentrate needed, and our y-axis represents the number of cups needed. And so here's this red line. So right away we know that this relationship is proportional because it starts here at the origin at 0, 0, and it is making a straight line. So in order to make a straight line like this, it has to be going up at a constant rate, right? A constant unit rate. So the question is, can you identify in this graph what our constant of proportionality or our unit rate is? Some of you may have noticed that from 0 to get to this red line, it goes up 3 over 1, and it continues to do that. And that going up 3 over 1, up 3 over 1, up 3 over 1, creating these points, 1, 3, 2, 6, 3, 9, right? We're making a table. Show us that it's going up 3, how much our y is increasing by how much x changes, right? This is the y, so it goes up 3, up 3, and that's how much it is on our y-axis, that vertical change, while the x is going over 1, over 1, over 1, and that's that horizontal change. So it's always the change in y over the change in x. And because that keeps happening, we could say that that's our unit rate. Others of you may have noticed from 0, 0, this first point, 1, 3, where our x value is 1 and our y value is 3. We had already determined that this graph was proportional because it starts at 0, 0 and makes a straight line because of these stair steps. So just like a table, if we know when our x value is 1, whatever our y value is, this point can tell us what our unit rate is. So from there, can you identify and write it down here what our constant of proportionality is and our equation for juice from concentrate? That's right. If you said that our constant of proportionality or our unit rate was 3 and that our equation was y equals 3x, I'd agree with it, and it checks out. If we put 1 in for x, 1 times 3 is 3. If we put 2 in for x, and we look at that on our x-axis, 2 times 3 is 6. If we put 3 into our x variable for our equation, and look at that on our graph, 3 times 3 is 9, and that's what it says on our graph. So we know that we have correctly identified our constant of proportionality and correctly written our equation because it matches what we see on the graph. Now, based on what this graph is about, can you determine what does the point 39 represent in regards to making juice from concentrate? It may be a good reminder to remember when we see an ordered pair or a coordinate written like this, just like we used here, the first value is always our x value, and our second is always our y. So what does the point 39 mean? Well, since the 3 is our x value and the x is the cups of concentrate, for 3 cups of concentrate, we would need 9 cups of water because the y value 9, y values represent the cups of water. So for 3 cups of concentrate, you would need 9 cups of water to make the juice. Let's take a look at our second graph. So let's go through that process again. Here's our second graph. Can you determine what it's about? It's really important to read the title and the labels always on a graph to be able to know what is the data that it represents. So since it says cost of postcards, that's telling us the main idea. And since our x-axis is labeled the number of postcards, we know that these numbers on the horizontal axis are representing the number of postcards purchased. And this on our y-axis is the price, how much it's going to cost us to buy that number of postcards. So using some of the strategies from our last graph, why don't you pause the video here and see if you can identify what is the constant of proportionality and turn that into an equation in the form of y equals kx. And if you're really feeling like going for it, go ahead and answer this question. What does the point 7, 3.5 represent in the context of our data here? So some of you may have noticed that we can build these little stairs, right? We could have built bigger stairs, but it's helpful to use this when x is 1 because we want to remember that a unit rate or a constant of proportionality is always with our x unit being simplified down to 1. So with these, it looks like it goes up 50 cents over one postcard, up 50 cents over one postcard, up 50 cents over one postcard. So for every number of postcards that increases by 1, the price is going up 50 cents. Others of you may have focused in on the point where x is 1, just like on a table, from a proportional table. If we know the table is proportional, we can focus in on what is this point when x is 1, what is our y value. And in doing so, we see when x is 1, y is 50 cents. So that would tell us that our constant of proportionality, or the unit rate, is half, or 0 50 cents, since we're talking about price. And our cost of the postcards equation would be y equals 1/2 x. And as we did before, we can always plug in some x values, multiply it by this unit rate, and make sure that that's what our y value equals. So we already did that for 1. 1 times 50 cents is 50 cents. 2 times 50 cents is $1. 3 times 50 cents is $1.50, so on and so forth. So in checking that against our graph, we know that we have correctly identified our constant of proportionality, our unit rate, as 50 cents, and we've correctly written our equation. And lastly, we're being asked to determine what does the point 7 and 3.5 represent about the data involving the cost of postcards. So what did you think? Well, View said that the cost of 7 postcards, since that's what our x variable represents on this graph, is $3.50, meaning that's the cost or the price to buy 7 postcards, since the price, 3.5, is what is being represented on our y-axis, I'd agree. That's going to conclude our video today on proportional graphs and equations. Please make sure that your notes are complete, and we'll do more problems like this together.